Now I'm going to show how to configure an empty database so that you can start the Easotope server and get ready using it. When you first connect to a database that's never been accessed before, that's never been set up before, the database gives you a message saying that you need to set the admin password. Now I'm going to just type admin here for the admin password. That's a really bad idea for your server. This data is probably going to be available on the internet, and if you just leave the password as admin, then other people can access your data and delete your data and do all kinds of terrible things to your data. So you should really choose a secure admin password that only you know. Now the database has been configured, the admin account has been created, and when we start up Easotope, we're ready, we're logged in as the admin user. So if I go to the Login Info tab, you can see that the admin user is currently logged in. And this tab allows us to do things like change the password of the admin if we decide we want to change it, or set the time zone that this user uses to see dates, for example. So when a date is shown on the screen, it's formatted for the time zone that's selected here. Users can also check for updates automatically whenever they start Easotope to see if there's a new version available, or you can see what permissions the logged in user has. In this case, the logged in user has all permissions because it's the admin user. Going to the All Users tab, here we can create a user account. And it's a good idea to create user accounts even if you're a nice friendly lab where you trust everyone, because this way everybody has their own password, and as you're adding new data to the database, it's automatically saved under that person's name, so you know who added what data, what date, who owns what samples, things like that. It's just better to have everybody have their own passwords, but it's of course not required. Creating this account, I'm going to give it admin permissions, which means that this user can do pretty much everything that the admin account can do. And then I go up here and save, and now the user account's been created. Now I can log out, start Easotope again, and this time give the new username and password and be logged in as this user. So now under the login information, I can see that I'm logged in as John Morphin now instead of as the admin. Next tab to look at is the mass spectrometer tab. Here you have to configure any mass spectrometers that you have in your lab. My lab is poor and we only have one, so we're going to call it mass spec. No need for a more creative name. And in the descriptions we can describe like where it is, or so that a student might find it. If you have more than one mass spectrometer, you can describe it here or whatever you want to do. The description field doesn't actually have any meaning to the software, it's just there for your information, so you can always type whatever you want here. When I save the mass spectrometer, I now see the data that I typed, and I'm allowed to enter a reference gas and correction intervals for this mass spectrometer now. For the reference gas, I'm going to say that this reference gas was added to the mass spectrometer on March 1st. And let's say at 3 o'clock in the afternoon. It has a carbon value of minus 3.57 ppb and an oxygen value of 24.96. But we're going to make this SMO. Here I can hit save, and now this new reference gas has been configured. So any standards or any data that is added to Easotope after this date will use these numbers to do corrections. Now we have to add a correction interval to our mass spectrometer. A correction interval is something that's specific to Easotope. It's probably not a term that you've heard before. It's one of the few things in isotope geochemistry that we kind of had to invent for this application. A correction interval is basically a period of time where all your standards are comparable to each other. So when would you change a correction interval? A correction interval might change if, for example, the mass spectrometer was vented or a filament blowout or something like that. Something that changes the behavior of the mass spectrometer, and at the time it happens, you no longer trust the standards from the day before to correct data the day after. So you want to create a break in time when data points before and after don't influence each other. A correction interval also has to indicate which type of analysis it's going to be doing. So there's various algorithms that Easotope knows how to do. Here, there's 4 listed here. And we have to say, how do we want to correct the standards and samples that are done in this correction interval? What algorithm do we want to correct, to use to correct this data during this time period? For ours, I'm just going to say I want to do normal carbon dioxide bulk corrections on any standards or samples done during this correction interval. And then I can go up and save. And the correction interval has been created. Now the data on this correction interval is right this minute, right now when I'm creating it. So the correction interval can only be used to correct data after this date. If I want to add any historical data to my database, then I need to create correction intervals in the past to encompass those standards and to indicate what replicate analyses I want to do on those past runs. But for right now, it's not really necessary. If we go to the Sample Type tab, you see that various sample types have been added for geologists. So for example, Easotope already knows about calcite. It knows that calcite generally has an acid temperature associated with it. It's configured with 4 different acid temperatures here, and these are the acid fractionation factors and the references to those acid fractionation factors. These values are changeable. If you don't like the acid fractionation factors, or if there's new research, you can just change these data, but the data is preloaded into Easotope for your convenience, and it's available for aragonite, dolomite. Carbon dioxide is a special case because there's no acid temperature associated with it. One other thing to notice about the sample types is you can, if your lab always uses the same acid temperature, you can avoid having to enter this in the future by setting a default. So I can say I want my lab to always use 90-degree acid temperatures. I can override this at a later time, but right now this is a default that will make my life easier. So I can save. And now any calcite data that I add in the future will automatically assume a 90-degree acid temperature. Now we go on to the Standards tab. The Standards tab is where we enter the different things that we're going to use as standards when doing our measurements. I'm going to add 2 standards here. I'm going to first add a Carrera marble standard. Here we get to choose a graphic for our standard. This graphic is used in graphs that we'll see in the future. So we get to choose a color and we get to choose a shape for Carrera marble. You can choose whatever you want, and you'll slowly learn to recognize these things in your lab. Sample type, a marble is obviously a calcite. And now I can configure various standard parameters, things that I know about this standard. So I'm going to say that carbon is 2.21 ppb, oxygen is minus 1.82, that's also ppb, And I could also calculate, I could also configure the cap47 value, which is a clumped isotope value, but because I'm only doing bulk isotopes in this particular correction interval, I'm not going to configure that. So now I've saved a standard. Our Carrera marble is ready to be used. And I'll also add an ETH3 carbonate standard. We'll choose a different color, something a little nicer, color and shape to represent our ETH3 carbonate. And because it's a carbonate, it's a calcite. And we say our carbon value is 1.81, and our oxygen value is minus 1.77, also PdB. Now we have two standards that Easotope knows about that we can add data for in the future. There's three other tabs in the configuration. The replicate analysis tab explains a little bit of information about what the replicate analysis does. So here, CO2 bulk analysis, it explains information about it, what steps are involved in doing that, what columns in the tables are modified, things like that. This is kind of advanced information that's not really necessary. It's just displayed here mostly for debugging purposes. So replicate analysis you can pretty much ignore. There's nothing to configure here. Sample analysis is very similar, and again, there's nothing to be configured here. That explains what kind of analyses can be done on samples. And our final tab is the constants tab. This tab shows us which constants Easotope has configured and to do the various calculations that it needs to do. References are given. Some of these are not verified yet, but should be accurate. The constants are only displayed here. They're not actually modifiable. They could be in the future, but at the moment the current version of Easotope doesn't allow that. So that's it, and our Easotope database is now configured and ready to be used. We're ready to add data, and we can go to another video to see how that's done.